I'm Robert Fildes, and I'm introducing these two sessions. For logistics reasons, they've been swapped over, and we're going for the next hour or so to talk about the changing role of demand planners and effectively their role being potentially changed substantially by the developments in AI and machine learning. But the panel will be pronouncing their words of wisdom shortly. The session of Paul Goodwin and myself talking about lots of empirical evidence on the role of judgment is swapped to this afternoon at, I think it's 3:10. It's in the program anyway, yeah, yes. Judgmental adjustment. We'll be talking about that, but not in this room, in another room. So I look forward to seeing you then, and I look forward to a stimulating and preferably controversial discussion. And hand over to the chair, Connor.
Well, thank you very much, Robert. Hi, everyone. I'm Connor, Head of Communications at Lokad, and I'm very pleased to be joined on stage by an illustrious panel from academia and industry. To my immediate left, Alexander Tikhonov, business and product developer at Lokad. To his left, Dr. Sven Krohn of Lancaster University, CEO and founder of iCast. And last but very much not least, Nicola Vanderput of Subchain. Now, the topic of today's discussion, as you can see, hopefully on screen, I've actually omitted my own name, sorry. Demand planning and the role of judgment in the new world of AI and machine learning. Now, I'm quite confident, given the people involved on stage, that this will be a lively exchange of ideas. And I think any advancements in technology typically raise questions of how those advancements will impact human involvement. So, very much looking forward to hearing our three panelists discuss that. Now, before I get into it, time is a bit of a scarce resource, exceptionally scarce today. So a little bit of admin, how this section will work. Each panelist will have 5 minutes to present their perspective, relative to the topic. First will be Nicola, then Sven, and finally Alexei. Following that, I will ask some questions designed to tease apart some of the details and the implications of their perspectives. And given how that goes, if we're all still on speaking terms, then hopefully some questions from the audience. What I will say is hopefully, or rather please, if possible, given how scarce time is, do have some, wood shop the ideas before the mic is handed over, rather than like a monologue followed by a question mark, please. But with that, I hand over first to Nicola. Please, your perspective relative to the topic.
Thank you, Connor. Hello, everyone. Great, I have the slides. Perfect. So let me introduce to you the vision I have for demand planning excellence at the age of machine learning, and how basically you can, for supply chain demand forecasting, integrate machine learning together with human enrichment. So you have 4 steps on the slide. Let me explain that. The first main thing for me is to see demand forecasting as an information game. So basically what you want to do, what it means is you want to collect as much data, information, insights, however you call it, about future demand. That could be your promotional calendar, how much advertisement you're going to make, point of sales data, inventory located at your client, orders you already got from your clients in advance, all of that. And it will be different for some industries, that's totally fine, but basically my point is the first step is find information about what's lying ahead. You are a journalist, a reporter, a detective, go and find this information. Now, once we have all of this information, data that can be structured needs to be fed to machine learning. And you want to create a machine learning demand forecasting engine that is automated and bulletproof. By automated, I mean that it's a tool, it's an engine that does not require any manual modification, review, or fine-tuning by human. It's done by maybe a data science team, or it's done automatically. So it's fully automated. Bulletproof means that your machine learning engine needs to react to most of your business driver, namely promotion, prices, shortages, maybe advertisement, maybe the weather, things like that, holiday and so on. So it's bulletproof to most of the business driver, and it's fully automated. You don't need to touch or review it. Once you have this, humans, so demand planners, can still enrich the forecast based on the information they found that are not included in this model. So let's, for example, imagine that they call your client, and one client said, well, it's really, really a tough time. I will not order this month. The client will not call the machine learning model. The machine learning model is not aware of that. The planner is, so the planner should review the forecast and enrich it because they know something that the model is not aware of. Final step, forecast value added. This is an absolutely critical step. I would even start with this one. It means that we need to track the added value of everyone in the process. So we need to track the forecasting accuracy before and after the enrichment to ensure that over time, their enrichment adds value. Of course, everyone can be lucky or unlucky at times. That's totally fine. Not every single enrichment will add value. But what we want to prove and to show over time is that, in average, these enrichment add value, so it's worth our time. Voilà, that was my vision in 4 steps on how to integrate machine learning and demand planners.
Well, thank you very much, Nicola. Now I'll hand over to Sven. Thank you.
Yeah, thanks. Sven Krone from Lancaster University, assistant professor there with probably almost 2 decades of research in AI and forecasting. So I'm completely biased towards AI. I have to say that up front, right? I've been trying to get AI to work in forecasting for many, many years. So just that you're aware of the fundamental bias. At the same time, we spun off a small company there where we've been trying to help large multinational companies leverage new technology. And looking back at those decades, it's excruciatingly hard, right? I think we have to address today, hopefully on the panel, some elephants in the room. While the vision has been there for many years, we can replace statistics with AI, we can replace that with statistics. Actually, we've not been terribly transformative when it comes to looking at the demand planning processes, I think. So that's my fundamental bias when we're looking at this. Some of the experience I can share is that I've trained a lot of demand planners in trying to get them to appreciate some of the exponential smoothing algorithms and ARIMA algorithms out of there. I can tell you that is not a pleasant exercise. So they're slow to adopt to some of it. It's a pleasant exercise with the demand planners, but it's very hard to get them to accept some of the simpler technology. So I think we'll later on talk a little bit about what happens if that technology gets even more advanced and people have to interact with it. But the current state, roughly 10 years ago, there was very limited use of AI, although neural networks have been around for the better part of 60 years, right? Going back certainly to some of the early innovations, certainly the 1980s. But adoption has been comparatively slow. In the last 2 or 3 years, we regularly do surveys at practitioner conferences. We were just speaking at a practitioner conference, the ASCM, together in Brussels, and we did a survey in the audience, and we asked how many people are actually alive with a proof of concept in AI and ML, and roughly 50% of the audience were there. So that's up from 5 to 10% 10 years ago. Now 50% are doing a proof of concept. They're not in production yet, but quite a few are already in production, and we saw some great companies here already that are trying this out. You know, Sanofi is in the audience and a few others, so really interesting case studies. But what's also striking is that as many projects that succeed fail. So we had a large chunk in the audience where AI projects did not succeed. And I think it is exactly that intersection between embedding a technology into a demand planning process, which is much more than just the forecasting step if we're looking at industry, right? We have to look at master data management, data cleansing, prioritization, error metrics, running a statistical model, then potentially analyzing errors, identifying alerts, and then making adjustments to that. And by the way, even if you have a fully blown statistical baseline forecasting process, which even today the majority of companies don't have, Gartner has a beautiful maturity landscape of the different stages of the S&OP maturity. Very few companies are in the level 4. Most of them are between 1, 2, and 3. Even if you have a statistical process, how to cleanse the time series history, do it automatically or manually, that's a judgmental decision. Which algorithm to choose is a decision. Which meta parameters to allow to search for is a judgmental decision. So there's a lot of judgment. But I think traditionally we think about the judgment, the final adjustment of a statistical baseline forecast that is or is not understood. And maybe to look into the future, I have not seen a lot of movement or innovation when it comes to innovating the S&OP process as it was designed by Olli Wright. And I see executives getting seriously disgruntled with the lack of progress, the perceived lack of progress, although there is often progress in developing the processes. But I think there was a CEO of Unilever that said, we've got to get rid of demand planning, it doesn't work during COVID times. Some real challenges ahead for demand planners to keep their jobs unless they leverage AI. And I do think that there's a realistic scenario that AI, as you said, if you manage to do all of this, that AI will be able to replace demand planners even in the judgmental adjustment steps. But we're not there yet. So looking forward to see what your views are.
Well, thank you, Sven. Alex, your thoughts, please.
Thank you. My proposition will be radically different. And I think first we need to expand the scope, because demand planning exists in supply chain, and the purpose of supply chain is to make decisions under uncertainty, to make profitable decisions under uncertainty, under the presence of constraints. And can you switch the slide? And as far as this goal is concerned, my take is that demand planning is an obsolete approach, and judgmental forecasting interventions are wasteful, even if they help to improve slightly forecasting accuracy. Why is that? Demand planning is an obsolete approach because it presumes that we need to separate forecasting and decision making. And this separation inevitably leads to raw choice of simple tools, because we introduce human-to-human interface. We have to convey information in a very simple manner, and we choose point forecast, because point forecast everyone can understand. Accuracy metrics computations are simple, so we can argue about those points, we can adjust them up or down, but unfortunately this choice of tools prevents us from making profitable decisions. Why is that? To make a profitable decision, we need to assess financial risks and financial returns. And we can only do that if we capture the structural pattern of the risk. And there's only one tool, as far as I'm aware, that does that. It's called probabilistic forecasting, where instead of single point predictions, you come with an educated opinion about how all possible futures look like. What are the probabilities for different likelihoods? And here I'm not talking about demand. There are other uncertainties. For instance, there might be uncertainties of a lead time that you need to take into account. This is especially relevant if you're dealing with the goods shipped from overseas. Then you might have yield uncertainty if you're dealing with production of food. You may have return uncertainty if you're dealing with e-commerce. So there are multiple sources of uncertainty, and you need specific tooling called probabilistic modeling to combine all those uncertainties to be able to derive decisions at the later stages. Demand planning offers us only one version of the future, which is a point prediction, which is the most likely scenario, but we are interested at the tails of this distribution, because risks are concentrated at two extremes. Then demand planning perspective inevitably leads us to considering only one decision option. You have one point forecast, you apply either a safety stock formula or simple inventory policy, you derive one decision. But is this decision profitable? What if I increase it up or down? How my expected profitability changes? I cannot do that because my predictions are point predictions. I don't state any probabilities of likelihoods of those scenarios. Then the third problem with demand planning is that economic perspective is completely absent. We are talking about forecasting accuracy in percentages, or if we use various metrics that deal with accuracy in units, we are missing the financial perspective. So what we need to estimate the expected costs, expected rewards, and we also need to estimate secondary drivers, such as how do we compare inventory decisions for different products. Every retailer knows, for example, that having diapers in stock is much more important than having premium chocolate, because if you don't have the first product, then your customers will be disappointed. You will lose customer loyalty. Then demand planning prevents us from extensive automation. What are we going to automate? We are going to automate production of the endgame decisions, not just the forecasts. We need to automate the entire pipeline. We need to convert our raw transactional data into actionable decisions that already saying with respect to all decision constraints such as MOQs and other decision drivers such as price breaks. And last but not least, there has to be an ownership. Currently, there is no ownership over the end game decisions, because we have this transition process of forecast going to a different team, and then they derive the decision. And then you have a blame game. Oh, we made this decision because your forecast was inaccurate, or there was some judgmental increase of the forecast, and thus it led us to a wrong decision. So to summarize, demand planning perspective is obsolete, and we have something better. Thank you.
Well, we're going to agree today, but not on everything. Can I just respond to that? Because I think I fully agree with you on some aspects. I think you mentioned point versus interval or probability distribution forecasting. Agreed, right? But there's many software packages out there that have been doing that for many years, but practitioners ignore it. But I think we all understand the value of communicating not only the demand value, but also the risk associated with it. So, I mean, SAS has been doing this for a long time. Forecast Pro has been doing that, and even Forecast X has been doing that, but it's widely ignored. So why is it ignored? We probably should talk about, why demand planners don't understand interval forecast. I mean, that would be interesting. The other thing that you mentioned, which I think is also a good point, is that there often is a disconnect between demand planning and inventory planning, supply network planning, production planning, which would be beneficial to derive a holistic solution. But if you're thinking about large multinational companies, I think the processes are set out that you would actually drive decisions over tens of thousands of employees that are all intervening, and they don't share their knowledge freely. So, and the third thing, I think we have to think about what we consider. I think we all have different backgrounds in looking at demand planning. I come from industry, multinationals, maybe multinational transportation companies, fast-moving consumer goods. Pharma, you probably have more of a retailing and vision and background where these things can be pulled together. But what we see, I mean, there are very nice books by Charlie Chase, I think, of SAS, written about demand-driven supply planning. It's about the demand-supply reconciliation. It's as much a process to share information and to share expectations and risk management, exactly risk management, over a long-term horizon in S&OP, roughly looking at 6 to 18 months out. S&OE is looking at 1 to 4 months out. And it's that information sharing that can also be invaluable, irrespective of what the final one-number forecast is. So I don't disagree that some of the things we have to come a long way when it comes to the integration of decision making, but I think demand planning shares more than one purpose. But I think in the interest of things, we're looking at automation, right? Today, maybe AI is used in the context of automation, and we're looking at accuracy predominantly. But very few people actually look at information sharing. There's a few interesting papers on robustness of forecast. I mean, what happens if you change your forecast all the time with a very reactive machine learning model, and production planning just goes crazy because they sum it up over the lead time, and you get your overstock or your understock, and you introduce production orders. So I think if we can focus maybe on the demand planning process and the contribution of forecasting in demand planning, because the other stuff is supply planning and network planning, production planning, right? But that's going to make our discussion harder. But I fully agree with you that that would be an important thing.
Maybe with a short comment. Okay. Yeah. So my take was not that we need better information sharing or better forecast. My take is that we need to automate completely the decision-making part. We should not let supply chain practitioners be involved in the forecasting process, because supply chains are immensely complex. We are talking about companies even if you take medium-sized companies, 100 million in turnover, like in retail, they will have tens of thousands of SKUs, like hundreds of stores. You multiply one by another, and for every SKU location, you have to make a decision daily. Even if you have predefined decision cycles, such as, oh, I make this decision once a week, you better still recompute those decisions on a daily basis. Why? Because human bandwidth is limited. You need computer to be checking, like, okay, if there's a spike of demand, I better know it before my usual decision cycle, because I expect demand to be, more smoother. So you need to reproduce those decisions on a daily basis, even though the vast majority of those decisions will be trivial decisions, which is, we are not making a purchase today. You see? So the human bandwidth is very limited, and when we talk about sharing information between humans, we are wasting time. We need to automate as much as possible. We need to be capitalistic. We need to build assets, decision-making robots. Then only we can get profitability out of supply chains.
Would you mind just going back to my slides for a minute? I'd like to
Absolutely.
to structure that. So I'll start from my framework, and I would like to make it even more extreme to continue the discussion from there. So I think we all agree that we only make forecasts because we want to make great decisions. And we would say, well, maybe this type of forecast would be better, this type of forecast, this granularity, this horizon, probabilistic, point forecast, and so on. But we all agree that we make forecasts because we need at some point to make decision. Now, why are we so inclined towards automation, all of us here? It's because we have to make so many forecasts and so many decisions at scale, and we don't want variability. If you have human, you have an issue of variability, you have an issue that it is so many forecasts and decisions to be made, and so on. Now, the way I see forecast, again, it's only about how much information can you process and how good are you at processing this information. So I want to have a model that is as good as possible at dealing with as much information as possible. And this forecast could be probabilistic, it could be point forecast, that's fine, as long as it can process as much information as possible. Now, I don't think today with the technology we have, it might change in 10 years, we could have a single model that can cope with all available information in the world. Let's take very simple example. The COVID, let's imagine it's mid-March 2020. If you have a forecast engine, even with the best machine learning technology we have today, you know as a human, COVID is going to get there, and the state of the world and the city will change in the following weeks. Your model is not aware of that. Now, you could have a point forecast, you can have a probabilistic forecast. You as a human, you still need to enrich and review that because you have access to information and you can cope with information that your model has no access to. So for me, the discussion of should it be point forecast or probabilistic forecast has no interest in this discussion because the conclusion is still the same. It's about how much information can you feed to your model, as much as possible. And if you cannot feed certain information to your model, then it's time for human to enrich that. And that's why it always makes sense to have a single last human who's able to review some decision or some forecast based on some information that the model cannot process.
I think we're talking about different industries here when we're looking at demand planning. I'm fully with you that if you're in a retail space and you have tens of thousands of decisions to make on a daily level, then you need a significant degree of automation. And probably automation is one of the core aspects that you have to do. But I mean, we work with retailers in the UK quite extensively for some time, and even there, adjustments are made across assortments, for things where uncertainty rules like extreme weather effects, or what is the effect of COVID closures on shower gel versus on toilet paper in Germany, right? So I think this human in the loop thing is one thing that comes in very late with very few exceptional overrides. And forecast value add is showing that this is helpful. I think we've seen from some of Stefan's presentations and others. But if you're looking at a pharmaceutical manufacturer, for example, that has maybe 200 to 400 core products, they're quite manageable by a human. I mean, why are all these companies getting by? We did surveys, and roughly 50% of the companies use very simple statistical measures. They're getting by, they're profitable, they're growing, they're agile in their supply chain, they have all embedded S&OP. So there's a whole spectrum of problems that we have. And I think that's one of the things that I always love at this conference. All these different forecasting flavors come together. We have people that are showing us electricity load for smart meters. Yes, you have hundreds of thousands of smart meters with minute-by-minute forecast. There's no human intervention feasible. But you have fast-moving consumer goods, or there was a presentation on pharmaceutical products in pharmacies, for example. In a retail space, it's manageable, but it's probably it's tedious, and probably if you make many decisions with a big team, you can get it wrong more often. But if you have very few important A items with that you understand really well, let's say in a pharmaceutical company, we looked at vaccines, for example, that are well understood. I think so. There are different flavors of demand planning, right? What we're doing in forecasting is as heterogeneous as products and markets are, and that's the beauty of it, right? That's why we all sit at the bar and we talk about forecasting. We talk about completely different things. But I'm fully with you. So if we talked about retail space, I'm sure that automation is feasible, right? The inventory decision together with the forecasting decision is much more feasible than if you're maybe looking at spare parts planning for a nuclear reactor, who are also doing demand planning, by the way. But okay, we agree to disagree that the world is big enough for all the different software packages as well in order to have specialized solutions. That's why big companies like SAP have specialized solutions for retail, and they will work different than for consumer goods and pharmaceuticals and industry or for other areas. So I think we do agree, just coming from different points of view.
Alex, do you wish to comment?
Yeah, just a slight comment. Yeah, I cannot agree with the proposition that people need to intervene in the forecasting process. Where people can add value, they can add value at the inputs of this decision engine to clarify data semantics, to bring more data, to explain engineer who is crafting all those algorithms or decision engine to explain how the data are used in business, so he has a better comprehension of the picture. And then they can add value at the end, checking out the decisions that decision engine is generating and find out those insane decisions or inaccurate decisions in their opinion. And then revisit this numerical recipe to find out what's wrong, what are the assumptions that are wrong, why is it making wrong decision. Because if they intervene in between, they touch forecasting or their override decision, this is like your resources are being consumed instead of being invested. First and foremost, you need to look at the ways, how can you improve this robotization? Because if you do it manually, you are wasting time. And you should start from decisions, by the way, not from the forecast. Because what if I had MOQ of 100 units and you came up to me and said, oh, now I have better forecast. Instead of 50 units of demand, there is a 55. Well, I still have MOQ. So from my perspective, both forecasts are kind of irrelevant, despite the fact that, yes, one is more accurate. I'm still making the same decision. And the fact that you invested more resources in producing more computationally expensive, potentially, forecast that is more accurate, you achieved better forecast accuracy, but overall, we are in net negative situation because we are still producing the same decision while investing more resources. So that's why I'm against touching the steps of the process manually. Revisit the whole recipe in order to improve the automation, to make it more robust, more reliable, more sane.
It's just a pity we didn't have the discussion from Robert and Paul beforehand. We were probably in the afternoon looking at forecast value add, because we have a lot of evidence that on top of advanced statistical methods, judgment can add significant value on top. And I think the question that was coined here today is, can machine learning overcome the value add of statistics and judgment on top? Or is it the same? And then I think the total cost of ownership question is a good one, right? Which one is more efficient? I'm pretty sure Nicola has lots of examples that you've mentioned before, or you reported, where you are actually automating the whole thing and is adding more value than actually doing judgmental adjustments. But yeah, let's move on to the next question, maybe.
Yeah, well, actually, it's more of a segue, which is still actually a transition of a kind. It's to push forward to, I think, actually what is the foundational question, because listening to you, there's almost like an instrumental disagreement here, but there's an overall agreement, and it's actually, I'm going to come to you, Nicola, first. Something you said earlier, you said, and again, forgive me if I misquote, I'm paraphrasing, we use forecasting to make better decisions. That means that forecasting is instrumental in a larger process, which then raises the question, where does the value reside? Because if you're using forecasting as a tool to accomplish something larger, where is the value there? Is the value in the tool that builds the house, or is the value in the structure of the house? The house would be the decision in that analogy.
So I think you have two important questions with forecasts. You have, the first question is your forecast accurate or not? And again, we could have a debate on how do you measure accuracy, very interesting debates. Not the point today. Let's just imagine, first step is just to assess how accurate or good is it. The second question is, well, based on a given forecast, how good is your company at making the right decision? Now, unfortunately, the team doing these are different teams with different inputs, different outputs, different KPIs. I would not, from a supply chain point of view, we could discuss about an ideal dream world, but in a real world of supply chain, I would not blame forecasters or people making the forecast engine for bad decisions or for decision-related KPIs because they have no action on that. At the same time, you could have very, very bad forecasts, and you have the decision maker that either got lucky or extremely good at making good decisions despite bad forecasts. So you might get some very nice KPIs, business KPIs. Again, we could discuss what KPI is relevant or not. But we could have it in both in different directions. So for me, when I want to evaluate a forecast, I would not look at the business outcome. I would look purely on forecasting accuracy because I know that business outcome can be driven by so many other things that are totally out of the hands of whoever makes the forecast, machine or human. Now, what's very interesting, and I simulated that for a few clients, is that depending on the quality of your forecast, again, we could debate on how we measure accuracy, but depending on that, and especially depending on the bias, for example, are you very positively biased under forecasting, or do you have a tool that's properly calibrated? I hope so. The resulting supply chain optimization engine might go for very different policies. So the optimal policy or the optimal way to make decision might change depending on the quality of the forecast. So it also means that if today you go from a forecast that's extremely over-forecasting everything because your process is so politically biased to a forecast that's actually machine learning made, you need at the same time to review how your supply chain decisions are made. Because supply chain decision-making process, tool, engine, people rely on the fact historically that the forecast was always 30% too high. So if you change that, now you also need to change supply process as well. So both needs to be integrated, but from a supply chain point of view, I would evaluate KPIs independently as much as I can.
Thank you. Sven, your thoughts? Just to reiterate, the question again was, if forecasting is a tool for accomplishing something else, where do you ascribe value, or where does the value lie there? Is it in the quality of the decision or the quality of the forecast? Define those however you please.
I think we already touched upon that. So for me, demand planning, or going with the Gartner definition of demand planning and the Oliver Wright process, we're looking at from an industrial point of view, take pharmaceutical industries, consumer industries, they're normally looking at much longer horizons than what you're looking at, right? They're looking at saying 6 to 18 months out. Right? The expensive decisions are the strategic ones. You identify long-term plans, you identify forecasts, you do gap closing activities, you try to reconcile supply and demand on a much longer horizon. You don't have promotional information, you don't have weather information, you don't have disruption information. So this goes very much into scenario-based planning and end-to-end planning of scenarios that have to materialize into some inventory positions. So that's a long-term position. If you're looking at, I think, the majority of industry still have a 3-month frozen period, right? I mean, so that we're looking at the time frame outside that. SNOE, on the other side, which has recently been embraced by Gartner, looks at this very differently. So there, for the long-term horizon, I think transparency, communication, those are important things to brace yourself for, changing budgets, realigning budgets, reconciling volume value. It's a very aggregate process, right? You're looking at high levels of the hierarchy, you're looking at markets, you're looking at channels, but you're not looking at individual products, right? Then you're down in the basically in the day-to-day work, and that's SNOE. And in SNOE, I agree. There you have automated decisions, standardized decisions. Accuracy is an important thing. Transparency is still important, I think, which was often overlooked, or robustness. But I think 85% of all presentations at this conference are talking about accuracy. There's this whole session about robustness, which is good to see. But I think the most important innovation to measure the whole process is forecast value add. I mean, that is really, to take the individual constituents and see how they add value. That's a very management-focused view, right? Because you want to invest resources in where you add value. Unfortunately, it doesn't embrace things like master data management, right? It's hard to measure that. It doesn't embrace things like data cleansing, which I think is instrumental in order to get anything done in statistical forecasting. And it looks at the very end of this, towards the human. But we have a hard time measuring value add because as a forecast accuracy, typically cost weighted, volume weighted, just to see on aggregate, are they making the best decisions? With error metrics that the academics would not touch. But what they're looking at really is what is the value add? But we have a lot of demand planners that actually make a choice for a statistical algorithm in the tool. They can override the choice, but that value is attributed to the statistical algorithm, right? So I think there's a lot of value in judgment today, and it can be measured. And I think the majority of companies have taken that on, and value add is a good tool to that. And again, I'm looking at the long term and much less at the short term, where inventory performance should be linked and so forth.
Okay, thank you. I think when we talk about forecast accuracy changes, improvements potentially, and we relate to forecast value-added process, I think we are confusing the terms, because the better name would be forecast accuracy added, not value. Because value, when we talk about value, for me, it triggers financial perspective immediately, and financial perspective is driven by decisions. Results of your business depend solely on the decisions you make and how well you execute these decisions. So there's nothing else involved in this perspective, only decisions and how well you execute them. And when we consider decisions, like for instance, I have forecast number one, it leads me to making decision A, and forecast number two, it's more accurate. I know by how much. I know the accuracy difference. But the question, is this different forecast, more accurate forecast, leads me to a different decision? If not, then it's wasteful, despite being more accurate. So despite, apparent better value, the net negative, we have net negative from the financial perspective. And then if the decision is different, how do we evaluate that this decision discrepancy, like the change, like swiping from decision A to decision B, how much more profit we gain in comparison to the difference in the resources investments? For me, it's an open question. We can use both forecasting models to evaluate the potential returns of both the decisions, but it's a still matter of speculation because we don't have two alternative universes to test out two decisions. We finally have to pick only one. And then even more, decision value does not solely depend on the forecast per se. There are other considerations such as like decision drivers. Case in point, we work with Air France, their MRO wing for spare parts, for aircrafts. And just recently, so we've implemented decision engine with them. And just recently, there was a large purchase triggered by a robot purchasing several, like dozen, I believe, auxiliary power units for an aircraft, which is like, overall it's several million euros, triggered by a robot. And people like, oh, they go crazy, like, oh, it should be a mistake. But when they started to inspect, it turned out that somebody on the other side made an error and set the price quite lower than the average price on the market. And the decision robot picked up on those and immediately implemented execution orders. It has nothing to do with forecast accuracy, but this decision has enormous value. So you see, there's like, we are focusing on forecast accuracy, but there are so many other things that can influence the value of decisions. So I think when we talk about monetary value, we should not only focus on the forecasting. We should look at the entire process of how we deriving decisions, what goes into consideration, like what is our decision process, which things are important, which things are of a secondary concern.
Just to, I do agree, and you mentioned that before in the first round, that there should be an inventory decision and then you should evaluate it on inventory decisions, or and I think, to be fair, in academia, the majority of people have, the whole range of journals have taken this as good practice or as minimum practice. So if you're looking at the journals in the production economics, and you're looking at ISER, I mean the Inventory Society, that is good practice. You'll see I've seen quite a lot of presentations from academics here that actually measure the decision cost on trade-off curves over service level and lead times, and actually do give the inventory cost associated with it. that is something that I don't see in practice at all, right? So it's very hard to do in practice. It's hard to do it, but it's possible. You have to make assumptions, and of course the supply chain is complex. But I fully agree with you. The decisions cost should be good, but that goes back to Granger 1969 asymmetric loss functions. We typically don't have the decision costs, so we have to assume something. What I see as a huge gap, and maybe an omission, what this community has not been able to achieve, is to link this important. To establish the link between forecast accuracy, however you want to measure it, and the decision cost associated with it. So we actually had a research project. There's very few companies. Johnson & Johnson has released that in the past. So 1 percentage point in forecast accuracy, typically it's weighted, cost-weighted MAPE, equates to $8 million in finished goods inventory and distribution center, expedited production costs, and so forth. So they had a whole line how they established this. We recently presented something where we did a bottom-up simulation with TESA. There are some calculators out on the web that I don't fully trust, but I think that's an important thing, that forecasting errors are costly purely from the decision on safety stocks and inventory in the immediate next step. Not even going to production planning and raw material sourcing and long-term decisions. So I think that's a real omission. That's why I think demand planning teams and companies are still too small. If they knew how expensive their decisions were, how valuable forecasting is, we would see a lot more resources there. And by the way, TESA, it was roughly, of course it depends on the company size. We're not allowed to say the number. It's 1 Bugatti Veyron. Bugatti Veyrons have a pretty rigid price, so it's 1.5 million per percentage point accuracy in inventory direct translations. And we're working with a few other companies now to establish this, given the inferior inventory models. But this is a really important thing. You're solving the problem directly and show them the decision cost, but when the process is decoupled, you can still do that, and I think that's the missing pin. But I'm fully on board. Inventory or decision cost would be ideal. Inventory is a direct linkage that can be done and must be done. And it's being done by academics.
Nicola, nope. Well, then I kind of want to push forward with and sort of stitch together some points that have been raised, particularly around assumptions. I mean, assumptions, if that's an assumption by a demand planner, like, oh, this is wrong, I need to make a manual override, that's an assumption. An assumption goes into building a forecast or an automated model. So, I mean, these are distinctions, or rose by any other name. But my question is it reasonable to expect for management, so people without training in the things that we're talking about today, to have the same level of trust in automation, like an automatically generated forecast, versus a forecast that's gone through your desk, for example? And or Nicola's desk, or Alexei's, excuse me.
Thank you for the question. It's actually a very, very common question I get on LinkedIn and from prospect all the time. If you mind going back to my slide. Like the most common question, if I summarize it in just a few words, is how can I trust machine learning? And you could change machine learning by statistical tools. I like to change this question to, yeah, but how do you trust humans? Because people, I'm like, okay, Nicola, how can I trust you? How can I trust your machine learning? And I'm like, how can you trust your team? And that's, I find, the real question. And there is just, for me, one way to track that and to answer that. It's called forecast value added. And the idea, it's really, I'll try to really explain it in just a few sentences again. You want to track the accuracy of every single step in your process. That could be a human, that could be a machine, that could be information from your client, or the forecast coming from your client. Every single step, you're going to track the accuracy before this step and the accuracy before this step, after this step. So as you do that, and I would also advise that you compare the overall accuracy of your process against a statistical benchmark, which could be any simple model you could find for free. As you do that over weeks, over months, over days, depending on your horizon, you can really prove that some part of your process, could be human, could be machines, are adding value and are accurate. This is the only way to do it. And I would even go as far as saying, if you don't do that, it's like you don't have the lights on in the room, you're in the dark, you have no clue. And when I'm contacted by companies who want to drive demand planning improvement project, the first question is, do you track forecast value added? Because if you do not, there is no way you can know if my model is adding added value and if we're doing great or bad. So this is the first step. To answer the question, how do you know if I can trust machine learning? Is the same question as how do you know if I can trust human? And the answer is you need to track forecast value added.
I think, again, switching to the decisions, because how can I trust forecast? I don't know if forecast is good or bad unless I see what decision it recommend, which decisions I can derive using this forecast. And from that perspective, humans, practitioners, oftentimes have very good intuition. If you produce insane decisions, they will point out and they will tell you why. Like, if your purchase order is too large, they will tell you what it should be, what was the ballpark for good purchase order, and why they think this way. So tracking forecast accuracy, yes. Having humans in the loop of like doing judgmental forecast overrides, as I said already, this is wasteful. Pretty much because those interventions, they have very short expiration times. You see, you made override, it doesn't last for like yet another year. It will probably have an impact on your next purchase order, but not the one that comes after. So you see, you involve very expensive resource, very unreliable resource, because we should also discuss, we don't have time, but we should also discuss what is the process behind those judgmental overrides. They are like semi-quantitative in their nature. There is no rigorous process like for automatically generated forecasts where we can inspect and decompose and see what's wrong if it's wrong. So you see, again, you need to automate as much as possible. And how you gain trust? Well, in the same way, like you trust your weather application. If it produces consistent forecasts, if it says there is a high chance of raining, and yeah, most of the time it rains when it says it will rain, or different technology like spam filters, like think of when they just were introduced in email clients. We were checking the spam box very frequently because the percentage of misclassified emails was quite high. Nowadays, I only go to spam box when I know a person who is not yet in my contact list send me an email and I have not received it. And I go, and yeah, it's there. And I click, it's not spam, and it will never go to spam. You see, so trust is gained over time, and you need a process, we call it experimental optimization, when you fine-tune this decision engine. Once it starts producing sane results, all you need to do is to track the metrics. Yes, you track forecast accuracy. If it changes drastically, you need an engineer to inspect with practitioners what's going on behind the scenes, but you should never touch, you should never manually intervene into this decision pipeline. You want to fix what's broken and then let it run. Pretty much like you do with machines. You do maintenance, and then you drive your car.
Yeah, I think trust is an important question, right? I mean, it's not that, I think looking back at the last 10, 20 years, a lot of companies have tried to go live, for example, in the context of forecasting, with statistical forecasting. And why is there such a skepticism? Why have so many companies started and stopped it, started and stopped it, started and stopped it? We all know about overfitting. We all know how we run these sandbox experiments with all the future variables, where you have to be really careful designing things in a proof of concept, then in a pilot study running side by side, rather than burn this. And indeed, the majority, I mean, with so many degrees of freedom and meta parameters and so many leading indicators that can just leak into whatever, some decomposition, it's very, very easy to actually promise a level of accuracy that you do not see materialize afterwards. We've promised some accuracy, and then COVID hit, and the management didn't understand why we're not achieving that level of accuracy. To us, it was clear, to them it was not. But I'm saying, you know, trust was lost. Trust was, I don't think generally, technology acceptance is a topic in information systems, right? Technology acceptance is a big problem. There's whole conferences analyzing how you can convey this. And I think one way is it has something to do with the general acceptance of technology. Like, you know, most of us will be skeptical if you get into a driverless car in San Francisco, at least the first couple of times. Maybe not, but maybe in 20 years, everybody will be happy with it. So that's what you said, you know, the usability, you see nothing happens and so forth. And that's how you can build up trust. You also have to communicate things. But I don't think the answer is explainable AI. Everybody goes on and explain the algorithm has to explain itself to me. I mean, I've tried hard to explain what a gamma factor of 0.4 does over 12 seasonal indices that change over time. Right? No manager gets that, but the manager at the top has to have, he has to make the decision finally, does he trust this significant investment into inventory? Does he trust his team to be working effectively and efficiently? And I think for that, we've lost a lot of trust with statistics, possibly with some inferior software implementations that did state-of-the-art at the time, but they didn't, some of them over-parameterize, in-sample, one-step, lots of evidence here on model selection. So, and a lot of these innovations have not been taken up, but rather by younger and innovative companies. One step in between that we've seen work to build up trust in medicine. For example, there's an incredible case study on detecting breast cancer from images. And the machine, or the algorithm, was significantly more accurate, a much higher true positive rate, much lower false positive rate, with incredible costs to individual lives associated with it. And doctors would not adopt it. Just in the 1980s, they didn't adopt some of the decision processes because they didn't trust it. They trusted themselves more than others. And Paul has a beautiful presentation on heuristic biases and so forth, overconfidence. And there's Nobel Prizes awarded why we are that way, why we don't do it. One way in between that they found is, rather than automate with AI, you can build augmented AI. So that's a lot of the solutions we're building now. When AI can do outlier correction, but we actually highlight the outlier to the demand planner. AI can do model selection, but we rather highlight the ranking, what we think is meaningful. We try to explain what we see in the data. So we think this is highly seasonal and it has a disruption. So this augmented thing, also for medical doctors, it basically was, rather than giving you a classification, it actually highlighted on the picture where the cancer is probably detected. And not only did it give you a true false answer, cancer or not, but it gave you a probability of this being cancer, which allowed, in time-critical situations, to sort by probability and only look not at the ones that are clearly cancer and the ones that are clearly not cancer, but to look at the ones that were uncertain. And that's where the doctors could actually use their expertise, and suddenly they had a massive acceptance. So I think it has a lot to do with the design of the systems, the design of the decision process, and it's not all automation, because we have ABC and XYZ and new products and ending products. It's not, you can't automate, shouldn't automate everything, but automate some parts with AI, automate other parts with very simple methods that are transparent maybe, and automate others with algorithms that are robust. But I think for now, for the current level of acceptance and skepticism towards technology, although we all love GPT to plan our next birthday party, I think probably augmented AI is a good step to get acceptance, and then we can fully automate with AI.
Oh, sorry, Nicola, do you want to comment on that? Well, just to follow back on that, because again, you both raised very, very good points there. But I just want to tease apart one of the comparisons there. So I think, Alex, you gave the example of using a weather forecasting app, which is, I mean, meteorology. The foundation of meteorology has been probabilistic forecasting for quite some time. And then you compared it to an autonomous vehicle, or at least indirectly compared it. And I think we'll take that and just try and paint a question. So to use Alex's example, if everyone in the room were asked, you have to take a vacation next week, your only destination is Bermuda. The weather forecast says it's going to be a tsunami next week. Are you going to pay your own money? Are you going to financially invest your time, effort, and energy flying to Bermuda? Most people would say no. Now, take that exact same perspective, which is finance and probabilistic forecasting, put all those exact same people in a company and say, here is a prioritized list of rank-adjusted, risk-adjusted decisions that was generated by an algorithm. Oh, no, absolutely not. I don't trust that. So, again, is it selective lack of trust? Your comments.
If I may, I could make a short comment. I think that the true issue with human resisting adoption of new technologies in general, when we talk about automation, is fear of becoming irrelevant and displaced. And actually what happens usually is quite the opposite. Yes, we automate some parts where humans are just not financially efficient. Like, for example, we used to have translators for multiple languages to translate our own website because we publish a lot. And cumulatively, we probably spent like something 400,000 euro over the several years. And now, whenever we publish anything, it's translated through LLMs. We have prompts that take markdown page as an input and produce markdown page with all the markdown syntax, shortcodes, everything remain intact, and only relevant parts being translated into other languages. Costs have dropped immensely, like 2 orders of magnitude, 100 times cheaper it is now. So should we, and yes, sometimes we find occasional misinterpretation, but you can still get the point. Like, is it worth to pay 100 times more to a human translator? No. Now, do we still need human translators? Yes. Like, if you want to craft a legal document, you better use a human translator, because a single word, single comma, may cost you a tremendous amount of money. So, do we need human translators? Yes, we still need them, but in the different areas. And probably there will be a more need for human translators in this legal field than it was before. And same applies to supply chains. For example, there are entire areas which remain intact because of lack of available human resources. For example, very often when you want to pass an order, you don't know upfront if there is an MOQ. So you need to retrieve this information. You can use humans. You can use a copilot as an AI, but you still need human to retrieve some information that is poorly structured to feed it into your decision engine so that it produces decision that is compliant with the NMOQ with the first round. So I think we still need humans just for different types of tasks, which will be evolving.
I think you mentioned an important part when it comes to the acceptance of some of these machine translation techniques, because they've been around. IBM via voice used neural networks back in 1982, right? So they have been there, but the translation rate or the error rate was somewhere around 90% identification. So a human would have to go in and change quite a lot of letters. Every 10th word would be wrong, and that meant it was unacceptable because it was below a threshold that was deemed good enough. And now if you're getting this accuracy towards not necessarily a human level, but you get it above a threshold, then you suddenly have a massive adoption of technology. In forecasting, we're quite guilty of that because we have, I've seen implementations with, careless use of multiplicative models on time series with zeros. And if you have 10 examples over 100 time series that explode once a year, you have zero acceptance because the trust is gone, right? So you actually have to get to robustness in order to allow automation to take place. So I think it's a good point, and we have typically tried to build accurate models rather than robust models that don't work well. So neural networks always have this, also I think we're all biased because we're adopting to technology, not as much as my younger brother, for example, who just loves technology. So there's an age decision there as well. But what drives trust, I think, in a senior management board meeting, I know one very large software company is actually actively looking at LLMs. And there was a recent decision made. I think Eric Wilson of the IBF, the Institute of Business Forecasting, has a blog, and they're quite outspoken about AI not taking over the demand planning process and everybody will keep their job. But recently there were examples where actually in a boardroom an LLM trained on a majority of the knowledge that was fed in, the promotional information, the disruptions, the supply chain, and in the end there was a forecast and the CEO asked the LLM why this was the case, and people had different views. Marketing had a different view. Finance had a different view. The LLM was the only one capable of giving a comprehensible argument why this is the right number. And I think there's another. I forgot the bias that is there. But if you can tell a salient story about things, right, people will trust this. And so this also introduces trust, even if it's wrong, right? But so I think. being able to argue why that's the case. For a demand planner in a context, 1,000 products, you're sitting there with the CEO to argue comprehensively why you think in 6 months it's going to be twice the amount. You don't remember, you've been busy working all month on all these numbers, slicing and dicing them up and down, translating them to value and then getting top-down per channel adjustments, and then in the end you have a number that comes out. But the LLM was able to argue for that. And that's, I think, where we will probably see, who's going to say that an LLM cannot read all the sales and key account meetings, he cannot get all the funnel information in, he can justify the funnel, he can align that with supply values and can actually come up with an adjustment that is better than a human because it can just handle much more data. I think that's where we might jump over the trust and then we just go directly to accuracy. But there is evidence that these can provide trust because they can finally explain what's going on.
So I see an interesting question, and then I think we finally found a subject where I would disagree. So the first thing I would like to tackle is change management regarding adoption of machine learning for forecasting. As with any technology, you have people who are totally opposing that, and you have some people who are more in favor of it. And I see it on LinkedIn each time I post. I always get a few people often the same saying, this is never going to work. I would never do it. You know what? I just stopped trying to convince them. That's fine. Just stay where you are, and I will be working with people who want to make better supply chains. Now, I've seen multiple clients. I've seen great leaders. I've seen average leaders. I've seen poor leaders. To me, if you want to successfully implement an automated process, and we can discuss machine learning and demand planning, but we could discuss any process. You need, as a leader in the room, to give a clear vision for everyone in the room what is going to be the role in the future. I'm going to go back to demand planning, but then again, this would apply to any process. If you say to your demand planner, your job, and I pay you to change, do forecast, and modify and tweak the models, that's what people are going to do. And it needs to change. It needs to change to your job is to make sure that the data that goes into the demand forecast engine is as good as possible, and your job is to find information beyond what's fed to the model, and then based on that, maybe enrich the forecast if needed. If you don't say that, people will keep on modifying the forecast day in, day out, because they would simply feel that if they don't do that, they cannot justify their salary. So again, for adoption, it's extremely clear that we give a clear picture, which is again relates to my slide with insight-driven review and insight collection and so on of what people should do. Now, something I'd like to add is this explainability. I think it's an open topic, and I'm myself growing on that, but I would say that for me, explainability is not required at all. I don't know how my car works, I still use it, and I never try to send an email to Mercedes to say, well, I will only use it again if you can explain me how it works. I would never do that. I don't know how internet works, I don't know how this thing works, I have no clue, I still do it. If a supply chain, I think, relies on explainability or storytelling or stories to use a forecast and to trust a forecast, you will never be able to scale. Because it means that your supply chain and your process rely on the fact that some human have some persuasion capabilities to influence other people to use your forecast because they have a good story. For me, you need to trust the forecast because the accuracy, however you measure accuracy again, is reliable. And over time, it has been accurate, or the decision has been meaningful over time. You trust things, you trust process, people, models, because quantitatively, it's great, not because the story makes sense. If you just go for the story, it's going to be a failure. I've seen myself so many consultants winning projects because the story made sense, and then it never drove any value, because actually once you do the model, it doesn't create any value, but the story is nice. So that's why I would really try to stay away as much as possible, from the story.
Further comments? You're under no obligation.
On explainability and explainability, understanding what's going on, how decisions are produced, how forecasts are produced. I think I can talk only about what we do. So as far as what we do, this is quite straightforward. We try to approach problems with correctness by design principle, and one of the problems that we know upfront people will have is the lack of trust because they don't understand how things work. So that's why you need we call it white boxing element, which is whenever possible, use explicit models where you understand what parameters mean instead of some obscure feature engineering, but so that people can comprehend what's going on. And those models, they are not so drastically difficult to comprehend. I invite audience to watch our submission to M5 forecasting competition. And by the way, team of Lokad was ranked #1 in the uncertainty challenge. And if you watch this lecture delivered by our CEO, Jonas Vermerel, you will see that the model is quite simple, and you will be surprised how with this simple model you could achieve like state-of-the-art results. But yeah, it's possible. So it's not that you have to use like bleeding edge AI to achieve extra % of forecasting accuracy. In the end, in supply chain, you want to be approximately right, not precisely wrong. That's why we choose, for example, probabilistic methods, because they can show you the structure of uncertainty. And then when you have economic drivers, you can translate this structure of uncertainty into structure of financial risks. And you can make well-educated decisions that are risk-adjusted, as opposed to just some decisions that are ranked against achieving service level targets. So I think people can comprehend top-level story, like how do you do it and why do you do that? But at the lower level, if they're curious, they can also do that, but it is almost inconsequential. Once you understand the top level, once you see that decisions are sane, why are you willing to go down? Like, for instance, typically people use computers, but they are not interested in memory allocations, like how your random access memory is leveraging the computations. No, nobody is interested about that. Same about computer chips in your car. Like, yes, you have robot maintaining, shifting the gears, but like, nobody is typically interested in that. It isn't consequential. It will not make your drive safer if you know that. So.
Well, I was actually just going to ask for closing thoughts. Well, actually, I was just going to ask, because just to round that off, you do seem to agree broadly, the panel, that understanding the how of these methodologies is going to be beyond the scope of most people, if they do not have the requisite training. The what, like what is happening, be it greater accuracy or be it a greater decision, is comprehensible, because I just said it in a single sentence. But before we go, just maybe 30 seconds to close off, what do you see being the future of demand planners? Because again, I already can kind of guess your response, but in terms of Nicola and Sven, you seem to, and I don't want to put words in your mouths, but earlier you did seem to suggest, well, we're not there yet in terms of complete end-to-end automation from your perspective. Okay, well then, what is the future of demand planners? Will there be a position for them 5 years from now, 10 years, et cetera, et cetera? And
yeah, I think looking at the data availability out there and the technology adoption rate, there's definitely going to be a job for demand planners for the next much longer than 5 years, I'm pretty sure. Because also the pressure to restructure for companies or to innovate is not as big. If you look at all these initiatives for digitalization, right? For most companies don't even have cloud storage. I mean, it's surprising how some of the largest multinationals of Europe have actually been able to operate so well. So that's probably due to the amazing people that are there. But I do see that. But in the long range, I think we're really risking, if they're not adopting, if the software vendors are not adopting, if you don't automate, if you don't support decisions, meaningful decisions like history correction, and I do think that explainability is important, not to understand this is how a neural network works, but these are the input variables that were fed into this and can answer a question, have you considered the promotion has been shifted from week 5 to week 12? I think those are the questions you have to answer. They're much simpler questions. But I do think in the long run, with more data becoming available, it will be very hard for demand planners. So because the frequency of decision is increasing, we're going from monthly to weekly to possibly intra-weekly forecasting to also align with retailers. I see a lot more promotions, a lot more disruptions are happening. There's so many disruptions that it's going to be grow incredibly hard for planners to to tackle so much information in such a short time frame, and therefore I don't really think that in the long run they will be able to compete on the level of accuracy and reliability with machine learning models if all the data is there.
Oh, well, thank you, Sven. Nicholas, your closing thoughts?
Yeah, so to summarize in just 1 minute, what's the role of demand planners in the coming years, how it's going to evolve for me? These are people who are going to spend most of their time collecting, gathering, structuring, cleaning data, information, and insight, feeding most of it to machine learning model, are going to be automated to forecast demand, and the information, the insights that cannot be fed to machine learning models will still be used by these planners to do manual enrichment on these forecasts. But these planners will not spend time flagging outliers, manually correcting outliers. They will not spend time tweaking models, reviewing the fine-tuning, the hyperparameters of models or anything like that, or even selecting models. For me, these tasks should need to be 100% automated. Humans should not do that. The planners will focus on finding, collecting, and cleaning information and insights.
Thank you. And Alex, your closing thoughts?
I think that currently demand planning are occupying niche of software products called systems of intelligence, because there are typically 3 types of enterprise software: systems of records, those are ERPs and different other transactional systems, systems of reports, these are business intelligence applications, and systems of intelligence, this is emerging field. Those are the systems that can automate decision making, such as one of those is that Lokad is delivering to its clients. And currently, demand planners are trying to compete with this field. My understanding is that in the long run, they cannot compete. They will lose. Why? Because humans are great creatures. They are super smart. They can, if we consider single decision, they can outcompete a robot because they will always come up with a greater insight, something that the robot is not aware of, like some additional information, but this is not scalable. Humans are costly. We're talking about supply chains of immense scale, so we cannot scale this up. And that's the primary reason why, in the long run, they will be displaced. For the same sort of reasons, like in Paris, we don't have water carriers anymore. We have running water. Why? Because it's cheaper. Yeah, there are some still undeveloped countries where in small villages you still have people carrying water in buckets because, yeah, due to the economies of scale, running water is not an option yet. But even in those villages, at some point, they will have running water. So in the long run, they have no place. And at the moment, some companies already got rid of those.
Thank you, Alex. All right, well, thank you very much to everyone on stage for your insights and your answers. At this point, I'll turn over. Does anyone have any questions? And I will sprint and pass over the mic. Oh, of course, it'd be right at the back. Okay, good. So many rows, Robert. Sorry, whose hands were up? Oh, sorry. I'll go.
Thank you, everyone. My name is Bahman. I'm from Cardiff University. I just want to make a very short comment because you mentioned about profitable decisions. I just wanted to highlight, and actually this is a point about what Sven also mentioned about the spectrum. So there are thousands of even supply chains. They're not about making profits. So I think that's important to consider. But also about the spectrum, I think my understanding is the panel was more focused on the supply chain. But there is a whole spectrum of demand planning. I mean, if you think about it, there are millions of hospitals in the world doing demand planning. And actually, they're dealing with 1 or 2 or 3, basically, time series kind of thing. So my question is more about what consists of conditions, or what are the requirements to create automatic decisions, given that decisions are relying on forecast as one input. There are many other inputs. Some of them might be forecast, but majority probably are not. Thank you.
Whomever has the microphone may respond.
Baman, thanks. I didn't quite get, in what context did you say that was, that where you have 3 time series and they're also doing demand planning?
So the question?
No, just how you phrase this. Who has 3 times used to forecast? Okay, then I'll try to wing it anyway. I think
there is
hospitals.
No,
hospitals have Hospitals of course have a large stock of replenishment, important products like blood, lesser important products and so forth. Cancer treatment, medicine. Some of this make to order, make to stock. I think we focused very much. So my background is not in hospital or health systems. We very much looked at the industry side. Which industry, supply chain management, logistics, which is probably defined by Gartner. We're looking at very large multinational companies that introduce these well-defined processes that have been tried and tested, that measure forecast value added. I think you're right. It's probably applicable to many other industries, pharmacies and hospitals and so forth. But I have little evidence on the adoption there. But I think, for the logistics supply chain industry, which is roughly 1/6 of the world global GDP, right? So we're talking about 1/6 of the world global GDP that's mainly driven by very large companies. There we're really concerned about the lack of innovation with regard to these things. But it does not mean that it should not apply to some other places.
I mean, maybe the better terminology would be a service supply chain. For instance, in hospitals, you have demand planning for emergency services. It's not about products necessarily. It's about the service itself. So it is. I think my question more is about the automatic decision making, because as I said, there is a spectrum. From emergency departments, they are dealing with one time series actually, and this is maybe where you don't deal with millions of thousands of time series. So the question is, what are the requirements for creating an automatic decision making?
I think you're right. I mean, it's a very interesting. There are many interesting areas that we in the forecasting community have not paid as much attention to as others. Right? If you look at the 10,000 papers in neural network forecasting, I think half of those are on electricity, right? But very few are on pharmaceuticals. So it's a good point. I think we should pay more attention to the important things.
All right. Sorry, not to cut off, Nicola, you can answer the next question, but I do want to hand over to the next question.
Hi, thank you for a very wonderful discussion. My question is more on the role of judgment. So my question is, every expert has got different judgments. So there is a pattern of bias generating from human judgment, and there is a pattern of bias generating from the AI or ML models, be it any statistical model. So we have 2 biases from the human judgment and the statistical models. So how can we incorporate the bias from human judgment into the statistical bias to reduce the overall bias when we are doing demand planning? Thank you.
Thank you for your question. It's kind of a usual case where I work with supply chains, and one of the first things we do is to look at historically how has your forecast performed, and we see that they had very high or very low bias, under forecasting, over forecasting. It always boils down to a story. People over forecast because they want to be on the safe side, and most likely because the supply process is not good and they don't really know how to manage inventory. So instead of changing, for example, policies or safety stock target, instead they rely on very high forecast. Maybe they also have very high forecast because they want to be optimistic, they want to fit the budget and so on. And the forecast, on the other hand, might happen because people want to beat the forecast to get a bonus. So usually, if your supply chain creates very high bias, it's an issue of wrong incentive or wrong supply process, and you need to disconnect that, retrain people, maybe improve your supply process, and maybe make it impossible for some people to change the forecast if they have a direct incentive in making it high or low. That's for the process part. So we need to stick to people who don't have incentives in making high or low forecasts. For the model part, if you have a model that generates over the long run very high or very low forecast, too high or too low, I'm not saying that 1 month is wrong, of course. I'm saying that over multiple periods you have the same issue. That is very likely an issue due to how you optimize your model engine, and most likely due to the fact that the KPI that's used to optimize the model is not the right one. I would bet that it relies on MAPI, but that's another subject.
Thank you. Actually, can you give it to Alex just for a closing thought, because we do have to end in
but
about a moment.
I just want to add something to what Ritika said. I mean, I mean, when we're talking about LLMs, maybe taking over judgment and making judgmental adjustments, we didn't really go into that much detail on how that works. But there's a lot of evidence these days that you don't have one LLM to actually train on all the data to come up with one value. You would actually have personas that you would train these on. You would have a supply chain LLM, you would have a finance LLM, you would have a CEO LLM, you would have a marketing and a key account management LLM, all trained on different data. But often these biases come from different costs associated with the decisions for key account versus supply chain, but often you have different information. And what they actually see can lead to enhanced decision making if you actually have agents that actually then converse with each other and argue for consolidated process. So it's not uncommon to the good practice that we see in S&OP. You will actually see them reaching a consensus, and that consensus is more accurate than the decision of a single LLM. So they're already replicating good practice in human processes into these. And I think if you see these conversations, it's really scary, because it is like, the biases are there, the decision makings are there, and then you have somebody at the end that decides based on weighting the information. It's ghostly, yeah.
Yeah, on the same question, I think that bias is a problem of point forecast perspective, because typically why you want your forecast to be biased intentionally is because your forecast is kind of naive in terms of capturing the structure of the risk. You predict most likely future scenario, and then you assume that the model residuals are normally distributed, which is never the case, and that's why you introduce the bias that shifts your prediction towards where most of the risk is concentrated. For instance, to the right tail, like you want to forecast the tail probability of not meeting your service level targets, and thus you shift the bias. When you switch to probabilistic perspective, you don't need this bias anymore, because what you come up with is opinion about the future that looks like this future with this probability, this future with this probability. And as soon as you train the parameters, underlying parameters that capture the structure of the risk accurately enough, then all you need on top of that is economic perspective, like costs, profits, and some higher order drivers, such as those that let you to make trade-off decisions for, let's say, should I purchase extra unit of this good versus extra unit of this good, because you are constrained, your budget is always constrained. So with probabilistic perspective, you don't have this issue, because by design, bias is not needed.
Well, on that note, I'm aware we've now run a little bit over time. For anyone who wants to ask any follow-up questions, we'll tarry by the corner of the stage. But once again, Sven, Nicola, and Alexei, that's your name, right, Alexei? Thank you very much for joining us, and yes, enjoy the rest of the day. Thank you.